Hi everyone, I'm Nilufa, and I want to talk about the WCMP use case that we implemented through the PINS project. As you might have participated in our previous talks, you might be familiar with PINS. PINS aims at adding SDN capabilities to SONiC. SONiC is a widely deployed network operating system, and it has a solid foundation to support SDN. And with SDN, we can enable many features and capabilities that might not be easy to be implemented by traditional embedded control planes. SONiC, to make SONiC work with an SDN controller, we need to add the support of P4 runtime protocol. It's optional, so operators can choose to whether use the traditional SONiC or the PINS, means the SDN solution. So we modeled the SOI pipeline in P4, which we call it SOI.P4. And here is the PINS architecture. We added a few components. More specifically, we added the P4 runtime container that talks to the SDN controller, and it translates the P4 entities to the P4 runtime tables at the AppDB. The orc agent translates between the P4 runtime tables and the associated SOI tables in ASICDB. And here is an example that how we modeled this fixed routing block in SOI. In P4, we used 5 P4 tables to model the routing, and each table is associated with a SOI header. Now let's talk more about WCMP and how it improves the network functionality. WCMP helps to optimally distribute traffics into the multiple paths based on an associated weights, which is very helpful, especially in unbalanced network, which is the case in real data centers. There might be multiple reasons why networks are unbalanced, such as using different heterogeneous switches from different vendors, different generations. There might be link failures. So SONiC is using BGP protocol, which is using ECMP. ECMP equally distributes traffics through the network. So there is a presentation by Google on DCMP. So if you are more interested to know about WCMP, you can watch the presentation on the YouTube. So here we want to implement WCMP using ONOS as our SDN controller and SD Fabric platform. Here is the end-to-end architecture. At the very top layer, we have ONOS. ONOS is an open source controller that is hosted by Open Networking Foundation. It has several apps installed. SD Fabric Control app. It sees all the topology. It knows the links and the network, all the network statistics. So it can calculate the routings, the weights of the WCMP, and it pushes down through as a P4 entity down to the switches. Here we have a fabric of a 2x2 fabric of leaf and spine, and we are running PINS as an operating system. So as an example that how WCMP can improve ECMP, here consider 2x2 fabric of leaf switches, and you can this scenario is heavily unbalanced. We have 400 gigs link. We also have 50 gig links. if we use ECMP in this case, and we want to send traffic from L1 to L2, the weights will be 1. So what happens here is that some links are fully saturated, the other links are underutilized. So this is not the optimal case. Now, consider that we are enabling WCMP. Now, ONOS will calculate the weights based on the topology and program like leaves. Here you can see that the weights are 811. It means that we should send traffic 8 times larger, more to the 400 gig to spine 1 compared to the other spine. And here you can see that the traffic is now evenly distributed, not evenly distributed. The links are evenly utilized. It's kind of like a load balancer. And actually, the controller should react on the runtime to the network changes. So consider that we have a link failure. Now, ONOS recalculates the weights and reprogram the switches. Here, the best weights can be 411. And you can get a good near evenly utilization. We have a recorded demo on like a real fabric. If you are interested to see the demo, please stop by our booth in Experience Center, and we can talk more about this. Any question? Thank you.